Hello everyone, welcome back to my channel, and today I will show you a simple project, spam detection using neural network. It will be very easy using Python and we will be doing in very simple steps. So for this we can see that there is a diagram over here. It is actually a neural network project, so we will be classifying a simple SMS or a message into spam or ham, but we will be using a neural network, not a machine learning. Okay, so first of all, I will show you the diagram, actually the flow chart over here. So what we will gonna do, so over here, first of all, we will take the CSV and we will load the CSV in the model. Okay, so we have to load it first. Then the step number 2, what we have to do, we have to encode the target column, because the CSV we will be taking, it will not have the target column as 0 and 1. It will be actually written in text like spam or ham. So we have to just convert it. Okay, then what we will be doing, we will be doing the step 3, splitting it into training and testing part. And after that, what we have to do, the main important part over here, that is tokenizing. Tokenizing is actually what that the computer or the machine doesn't understand the words. It understands only the numbers like 0, 1. Okay, you know already. So we have to just convert it into the 0 and 1 so that the model could understand the words. So we will be converting the words into tokens, and the tokens is actually the numerical 0 and 1, okay, the computer language, and it will just understand, and then we will be fetching this into this neural network. Okay, so we will be using the sequential network, and then we will just train the model with it, and after doing that we will just test the model and make the prediction. So this is all we will do in this project, and I have made it very clear and easy so that you can understand it. It is not actually for the project purpose, it is actually for how you learn. Okay, so I think you will get it very easy. So let's go to the coding part. Okay, we have created a file named test.ipnb. So what we will do over here, first thing, we will just import some modules, or you can say import some libraries, and we will be needing that because we have to use that thing. Obviously, it's a simple thing. Okay, so I will just write it down very quickly so that the time will be not wasting. So just over here. So over here you can see that I have imported first the matplotlib, because the matplotlib is for training and plotting the history, not actually for the training, plotting the training history, and pandas for the data manipulations. Okay, TensorFlow for the building and training the neural network. C1 is for plotting confusion matrix. Okay, and the heat maps. Then we have imported the tokenizer. This is actually for making the tokenizing system. I told you as earlier in the diagram or in the flowchart. Then we are having this one. This actually to maintain a sequence, means patch sequence to a equal length, because we need to keep equal length of every word. Okay, we don't want to means take a word like different words length. We have to keep it as equal. And then we have taken the sequential for our neural network. It is actually the model. Okay, then we have taken some another inputs like embedding dense and global average pooling 1D. It's actually the layers which is we are using in the model, means in this sequential model. Then we have imported the test and training split, and then label encoder, and the last one for printing the confusion matrix and classification report. Okay, so all these things we will be recording, we will be needed for the our project. So here we have imported, so let's just run this over here. Okay, just wait a minute. Okay, you can see that it is actually done importing all the things, and it, so over here you can see that it is already run. And now what we will do, we will begin our step 1. In step 1 we will just load the data set. Okay, So just we have to remember that our dataset is not actually CSV, so we have to handle it like that. So we have to just give the column names as a label and text. Okay, so let's just import it. Okay, so okay, this is the main thing. Over here we have to modify. This is actually our technique to load this CSV, but it's actually not the CSV, so we have to just handle it. So what we will do, we will just keep a comma and we will just give the separation equals to T. Okay, this is actual. And then what we will do, we will just do is this. Okay, what's actually happening, we have given the header equals to none and the column name equals to text. The first column is actually text. Actually the text contains the messages, and this label is actually our target, which will denote it is actually ham or spam. Okay, so the first part is done. So we will just run this cell. Okay, so we got some error over here. Let's just debug it. And I don't think it's actually something we will needing over here. Okay, so sorry for my mistake. We will just have to take this thing. I have forgotten to replace the name. Okay, just we have to remove this CSV because we were not needing this. So we will just run it again. Okay, now it is done. Our step 1 is done. And then what we will do, we will just go to the step 2, which will encode this data. So what we will encode, we will actually encode the target value. Okay, so our target column is actually contains two, means two values, that is ham and spam. So what we will do, we will just actually making this ham 0 and spam equals to 1. Okay, this is actually what we will do. So let's just do the code. So what we will do, we will just level encode. Okay, so wait a minute, let me give us this one. Okay, so level encode equals to, we will just load the model, and after that what we will do, we will just have to load the data. Okay, means the data over here actually means the level. Okay, so I gave it this name, and we will just load level encoder over here and fit transform. Okay, okay, done. And it's actually done over here. What we have done, we have level encode this. Let's just run, and it is done. So we have successfully level encode our target value known as level. So we convert this ham equals to 0 and spam equals to 1. So let's move to the next part. And in our next part, what we will do, we will just split the data. Okay, so let's just do it. So let me write text equals to data, this one. Data's text equals to value, and same thing we will do just for the level 1. So the recommendation is coming, just press tab and we get this one. Okay, so just you have to remember this level is actually we are converted into this level enc, level encode. So we will be using this thing after making these changes. Don't just take it this one. Okay, means this is normal level. So we have written over here level enc. Okay, now what we will do, we will just train and test this whole thing. So we will be just writing the code x train. Okay, over here. So what we have done over here, we have splitted it first, and then we have given something that is test size 0.2. So it's actually for the testing part, because we will be using the 20% for the testing and remaining 80% for the training purpose. Okay, so over here we have written this code and we'll be just running this. Okay, so our step 3 is already done. Next, do our step 4. So the step 4 is actually the main part. So what we will do, we will just make it as a tokenized and the pad sequence. So I have told you it earlier, we will use this tokenized Y, and why we will just make this pad sequence. Okay, so tokenize is for making the model understand, because the model doesn't understand the words, it understands the numerical values like 0 and 1. And we have to keep the length in a same sequence, means same limit, so that it is actually needed for the input sequence, so that the model could easily understand the thing. Okay, so we will be just doing max vocab size equals to 1000. Okay, let's not give the 1000, let's give it 5000. Okay, now what we will do, we will be just giving the max length. So what we will do, we will just give max length equals to 100. Okay. So over here, what we have done, we have limited the vocabulary to 5000. So the most common words, and this one, we don't require this actually. And over here, the max length equals to 100. This is for the each input sequence. Okay, so let us run this. Okay, and after that we will just add our next code cell, and this is for converting the text into sequence of integers. Okay, before doing that, we have to just add a code that is actually for generating the tokenizer object with OOV token. So it's not actually converted into the tokens, but we have to convert. This is actually the initializing part, what we have done over here. So we have just maintained the size and the length, max length. So let's just convert it. So what we will do, just we will take a value name token. So tokenizer equals to, what we will do, we will just write the tokenizer, and then we will just write the num equals to max. So we have made the max size. Okay, now what we will do, we will just write the OOV for tokenizing. Okay, so what it does, I already told you, it actually creating a tokenizer object with OOV token. Okay, now we will just write tokenizer dot fit dot text. Okay, so we are training this tokenizer with the model, means not training the tokenizer with model, we are training the model with this tokenizer. Okay, so that the model could understand, so that the model will learn the index from the training data. Okay, so let's just run this. Okay, I created some problem. Let me just debug once. So now you can see that it's actually ran properly. And now what we will do, we will just move on to the next part. Okay, so the next part is we will have to just create a pad training sequence. I told you, because we have to keep the same length. So let me just write the code, and I will just explain you why I have written this code and why we require it in more detail. Just let me write the code. Okay, so we will just try the xtrain sequence equals to pad, this one, and then this one. Okay, and after that, what we will just do over here, we will just try the xtrain. Okay, so we have written this thing. Okay, so why we have written this thing, I will just explain right now. this one is actually for we are tokenizing and converting it into each messages into a list of numbers. For example, the sentence is win cash now, so it becomes a numerical digit, means it's converted into a numerical digit like 24, 132 or 76. Okay, win cash now, so it's actually for converting the sequence, means converting the word. Okay, and this part over here actually what we are doing over here, since the message have different lengths, so we pad them into make them all look the same length. Okay, and this is very needed because the neural network actually expects input of same size. Okay, it doesn't expect a random size and different size, so it actually expects the same length, same size. So what we are doing, we are using this padding equals to post to just add a 0 at the end of it if the message is shorter than the max length. So we have done this for this both cases, for the training purpose and for the testing purpose. So now what we will do, we will just come to our next step, which is actually building the model. So over here I have made some changes, and that is I have imported a module known as bidirectional LSTM. Actually it is for long-term memory, means it will store the data for the long term, and we will be using this, okay, in our model. So let's just write the code and then I will explain. Okay, so let's write model equals to sequence here. Then over here what we'll do, we'll just add a bracket. Actually it's a square bracket which we will be giving. Okay, so over here what we will do, first we will just embed this one. Okay, over here you can see that I have written this bidirectional LSTM model. So I will just cut it, I will just write the LSTM like this, and we will be requiring the 64, but we will be not requiring for the returning sequence. So we will just cut it down over here and we will just press save. Okay, so over here I have taken the fully connected layer and the activation function is redo, and for the output layer I have taken the activation function sigmoid. It's actually for means predicting the output for in the form of binary values in 0 or 1, because we actually are dealing with a binary classification, right? So we are taking sigmoid as an output layer. So now we will just run this model. Okay, so next thing what we have to do, we will just have to compile the model and we'll just print the model summary. So let's write model.compile. Okay, so then we will skip this one, loss equals to binary loss entropy and optimizer equals to add up and accuracy matrices. Okay, now we will just try the code to print the summary. Okay, so here I am getting some error, so let us just debug it once. Okay, it's actually for this double comma. Okay, now what we will do, we will just run this code. Okay, so over here you can see that we have got the total summary of our model. Over here the total parameters are 740. So over here you can see these total parameters over here. So these are the total number of parameters, and these are the total number of trainable parameters from the total parameters, and the non-trainable parameters, which is 0. Okay, this is the summary of it. Now we will just go to the next part. Over here what we will do, we will just have to train the model. This is the step where we have to train the model actually. So let us just write the history equals to, okay, model fit, and okay, like this. So over here you can see that I have passed the train pad and y train and epoch equals to 10. So we will just keep it like this, but we will just change over here. So what we'll do, we will just pass the training validation part over here. You can see that, and we will just give a weight, class weight. Okay, just write like this. Okay, so I've just passed it over here. Now we will just run this, and the epoch will be start running. It will just take some time because I have done 10 epochs. You can do it more than that. It depends on your code. Okay, and I have also taken the batch size as 32 over here. So let's just wait it for a minute, and it will be done for some time. As you can see that our training is done. Okay, it's successfully done. Now what we will do, we will just have to evaluate the model, that whether the model is trained properly or not. For this, what we will do, we will just have to check it once. So just write loss and accuracy of this one. So over here, what we have done is we are actually passing the loss and accuracy, and for this we have done it model.evaluate. Okay, for both the cases, model.evaluate, and we are passing this x test pad because we are evaluating. So we have taken the test one, and over here y test. And now what we will do, we will just print this both thing. Okay, for the loss and the accuracy, because we have already written over here, so we will just print over here. So let's just print it over here. So we can see that we have got the loss over here and the test accuracy. It's actually a overfitting, but don't have to worry about it. If you just change over here, you have to just change some code, and then whole code will be correct. Okay, for now. So now what we will do, we will just do our final step, which is actually predicting function. So we will just make a predicting function known as def predict spam, and we will just pass the text. So for that, what we will be doing, we will be doing a function. So let's just define a function name predict spam. And now over here, we'll just pass the text, and then we will just write clean equals to clean text, and then this one, and after that we will just write the pad equals to patch sequence, which is this one. We will just keep it a post. We will be just modifying this thing. So over here, what we have done, we have written this thing. We have passed this all the thing. Okay, the function we have created earlier over there. So you will just check the code over upper side, and you will see that these things are the same. Okay, so I will just add one more code over here so that the thing should be proper. So we will just change this, and we will just write label equals to this one, and we will just return like this. We will write level. So done. We have created this function. Okay, now what we have to do, we have to just give the sample messages for the testing part. For that, I will just use this one. Okay, We will be not taking this all the thing, but we will taking these things. We will be taking the three part, means three data. So we will be just passing this thing over here. Then it will just pass through there. It will just clean the text, and then it will be just tokenized. Then it will be passing over here. It will be actually doing making the words of same length, and then it will be actually predicting, and it will be just labeled again from the numerical to text in form of spam or ham. Okay, over here we can see that if the prediction value is greater than 0.5, then it will be just printing spam, and if it is not, then it will be typing ham. Okay, and then what we are doing, we are returning the label and the prediction score. Okay, and these are our messages. So our next part, what we will be doing, we will be just printing those messages over here. Okay, means we have to print whether it is spam or ham. So we will just run this, and now we can see that we have got our result. So this has to be the spam, so it is actually spam, and you can see the score over here. And this is actually the ham, means it is actually a genuine messages that hey, we are still meeting tomorrow. So it's not a spam, so it is over here, the confidence is 0.0. Okay, so and it is ham. And again, this is actually a spam, because you can see that the win cash prizes text win 1 2 3 4 5, this is actually a spam messages, and our model successfully detected that it is spam. So whole model is done. It is actually done with the neural network, as you can see. So you can modify this and make it more further better. I will give the whole code link in the description below. So just go over there, visit it, and make your own code right now.